Are you trying to figure out how to get the SKR Mini E3 version 3 to cooperate with the Big Mini12864 version 1 screen? Well, that's what we're going to go over in this video today. So if that's what you're looking for, you found the right video. Hey everybody, how's it going? This is Patrick with Stacking Layers. So today's video is going to be all about getting these two systems or components working together. The Big SKR Mini E3 version 3 and the Big Mini 12864 version 1. I think the version 2 actually has some different pins, but it should more or less work the same way. You would just need to figure out which pins are which on that board. But since I only have this one, this is what the tutorial's on. And I think this is actually the more common one that I see a lot of people having issues with. So that's why I decided to do it. Actually, I've seen quite a bit of people lately trying to figure out how to get these boards together. And instead of going, over step by step in chats and things like that, and trying to tell them where to plug things in, I decided, let's make a video. Let's get this thing so I can just show how it's working. So what's the problem? Why aren't these working? Well, if you're here, you probably already know. But if you found this video by search, you probably already know. But if you are here just because you want to watch my videos, well, thank you. But what's going on is the SKR Mini E3 board has only one EXP port. These are expansion ports, most commonly used with screens, and it only has one. But the screen has two, and both of the pins or both of these ports need to be utilized in some way or another for the screen to work. So basically what we need to do is make a custom wire. And that's what I'm going to go over. So the way we're going to be doing it, I'm going to be using most of the, if not all of the pins that are in here, some of the pins from the SPI for communication, and then one pin over here to activate the beeper. This thing has a piezoelectric buzzer on it. That's a little box right here, this black square. And that is the, so you can make beep sounds with it. And it's pretty nice because it has a multi-frequency capability, so you can do all sorts of fun stuff with it. And I'll just show you how to get that set up. Unfortunately, my microphone, for whatever reason, will not record the frequencies, the pitches from these piezoelectric things. I don't know if it's a setting I have or something. I have noise canceling off, but unfortunately, I won't be able to let you hear what happens because it just doesn't work on my mic. But I will show you how it works, okay? But that's near the end of the video. Let's get this thing set up. So first things first, obviously, we need to connect this. I'm going to be using DuPont cables. This is just mainly for, demonstration purpose to make it easy so you see what's going on. But I recommend doing something a little bit more robust, or at the very least, if you're going to go the DuPont route, get longer, nicer cables. And, the ones that are all attached together, obviously, I've ripped these apart. So you can get them as a whole ribbon, so it looks more similar to something like this, that the cables that it comes with. You can also use these plugs if you want to cut the other end off and split it off and things like that, because the problem is that some of the pins on this one here are going to be going to both. So you got some of them going here and some of them going there. So you have to have them split like that. But there is, there are ways of doing it. But basically, my idea is the easiest is to make your own custom cables. It's normally how I handle things. And so if you're going to go the DuPont plug route and make your own custom cables, I recommend buy some of the 5 plug connectors, because you can get these where there's 5 of them all in a row stuck together. And what it does is it makes it more robust. So it'll be, something like this. They're not actually separated. It'll be one solid piece. And because they're 5-pin rows, 2 5-pin rows, so it'll make it easier to connect things in and be more secure. Also keep in mind with DuPont cables, especially if you go this route using the standard singles, they can be kind of loose fitting in there. And so once you get everything plugged in and it's working, I recommend dab some hot glue around there to keep it in place. I don't normally like recommending hot glue, but for this scenario, these type of cables, DuPonts do have a tendency to pop out over, especially with printer vibration and stuff like that. They can find their way out. Your screen will go bad. Worst case scenario is they pop out and move somewhere else, and they accidentally short on some other pin. And you don't want that happening, of course. So dab some hot glue after everything's done, and it should be pretty stable. It's not going to damage the board, and if you need to remove it, if you just drip some isopropyl alcohol on the hot glue, it'll basically release the bond, and then it should come off pretty easily. So just a tip there. So what we're doing is getting this installed, of course. So first we have to connect it to make sure everything's connected together. And what I have done is I will flip over to the screen here. I've created this schematic, basically, or a diagram, so you can see it's all color-coded, so you know what plug gets plugged into where. And so as you can see here, this side, in case you're not worrying, I'll just do a line down the middle. So the left side here is the SKR Mini board, and then the right side is the screen. And you see the bigger picture here. it's sitting in the image. If it's not able, if it's not clear, it's sitting in the image like this. So you have EXP1 on the top, EXP2 on the bottom, and then obviously these are in the way with the text facing you. So that's how it's sitting in the picture, so you know when you're plugging things in how things are oriented. Okay, so let's get back over to the picture there. Get rid of that line. And so it should be pretty self-explanatory. I don't feel like I need to go over too much detail on here, but basically we have the EXP port down here is the large chunk, and then we have the SPI. The SPI are these pins here, and then the XP are these pins here. And then we have the IO. Now IO is really nice on this board specifically. There's 5 pins that are basically general input-output pins that you can use. You can program to do whatever you want. We're going to be using the last one, or the one that's closest to the outside of the board, since it's just nearest to the rest. And we're going to use that to connect to the beeping capability. That's the buzzer. And on the board for the IO pins, just to make it really easy for you to find right away, are these pins right here, these 5 pins. So we're going to be using this last one. So this group, 3 of them out of here and 1 of them out of here. That's what we're doing. And so, of course, with color codes, it is just connect the colors. Some of them that might be a little bit difficult to see the difference are the yellows. There's 2 yellowish colors. I'm kind of colorblind, so it's hopefully you guys can see these colors better than me. But we have the CLK. Obviously, it goes to one that says CLK. That's yellow to yellow. And we have this orangey yellow color, I think is what it is. And that comes up to here. And then there are the 2 kind of bluish colors, or what I see as bluish colors. So the MISO goes to that one. So it's nice that these are labeled that way because it's easy. They go to the same pins as shown here. But then the other one, this PB9 pin, comes up over here. I believe that's pretty much it. Maybe this one, the PD6, to me is a little difficult to see. I was limited with colors, unfortunately. So the PD6 goes up to this one here. And then the what was the other one that was close to it? Yeah, PB5. That one is coming over as one of the encoder pins. So that's coming up to ENCA up there. Okay, so those are just, for me, they're difficult colors. They look very similar. They look almost identical to me, but I can see a slight shade difference. So maybe you're just like, yeah, whatever, I can see the colors. You're colorblind. But I just want to point that out for other people that may be colorblind or have a color weakness, as they say, my eyes are. I'm not blind, it's just color weakness, but whatever. So that's that. So that's what we're going to do. We're going to connect. So pretty self-explanatory, right? So we have, I'm just going to start with the bottom here, which is 5 volt and ground. So again, 5 volt to 5 volt, ground to ground up here. So that's what we're going to do here on the boards. And I'll just do this first connection just so you can get a 100% clear picture. I'm sure you already understand what plugging wires in are, but of course my channel is kind of geared right now for helping absolute beginners also. So it's not just the pros here. And yeah, so the pins down here is where we're starting, these 2 last bottom pins. And that's the 5 volt on the outside, and the ground is on the inside one. So that's where we're going to plug them in. And when it comes to wire colors, you don't need to use the colors that are on my diagram or anything too conventional. So if you want to use a blue wire on the 5 volt, that's your choice. Colors on the cords don't matter. The only reason why there's multicolors is to help you follow where this one is plugged in from both sides. So you see red one there, you see the red one up there, then you know that that one's connected to that pin and that one's connected to that pin. So there's a lot of, I wanted to point this out because I see a lot of things, especially like with probes and other connections. People go and plug in things. It's like, well, I put the red one on the 5 volt, but then something happened. Well, unfortunately, not every company is going to follow an industry standard, because technically there is no actual written standard that it has to be those colors. It's just the more common or the most commonly used colors. So it, naturally you think black is ground and red is positive or 5 volts. But it, that could be with batteries, or it could be here. But there's other colors. There's greens that are used for 5 volts. There's all sorts of other things. And here, this is actually a very common color with red and brown, where brown is ground instead of black. So I'm just wanting to point that out because I see so many people messing up their boards using only the color of the wire to gauge what the wire does. So my main point is always trace where each side is connected to. Never trust the color of the wire. So enough of that. That's a little side lesson. So as you can see here, I have to double check. Yeah. As you can see here, I have the red on the 5 volts, which is the outside, brown on ground, and then that's going to go on the same here. So you can see that they're on the opposite. So, or they're both on the outside corners of the board, but this one is on the right one, and then up here it's on the left one. So make sure to pay attention to that type of stuff. So here we go. Red is the 5-volt, brown is the ground. So we flip them because that is these top pins here. There, that one, ground, goes over to this one. And there you go. So that's the first 2 pins connected. So I'm not gonna, obviously make you watch me do this one-to-one because, with my fat fingers and whatnot, trying to get them in here, it does take a little time. So I'm gonna go ahead and connect this now. I'll fast forward through that so you don't have to painfully watch all that time. And as soon as I'm done, I'll come right back. So there we have it all connected. So as you can see why I talk about these DuPont cables, you want to get longer ones because obviously these are too short. These are just quick jumper cables. So you're going to want to get the longer style. They do actually sell kits, if you didn't know, that you can crimp these. It's a full crimp kit. So it comes with all the little metal pieces and the headers. So you can make your own with long, nice wires. So that's what I recommend. But for just the demonstration purposes like this, if you do have a bunch of them loose like that, I again recommend after doing the hot gluing, make sure everything works, to zip tie them all together so it's kind of like having just one harness. Or you can even get like a shroud or something, a spiral cable holder to go around that stuff, just to keep them safe. You don't want these things getting caught on stuff or moving around. So as you can see here, everything is connected. Ignore these 2 wires. I just have 2 wires to Mini, and I don't want to tear them off that group. I'm gonna go back over to this screen here so you can see, keep in mind there are some that are not connected. So all the ones that are still left white, those are not going to be used. These top 2 that say NC, anytime you see NC, that typically means on connections, that typically means that it's not connected. A lot other things that it could mean is normally closed, but that's more if you're looking at like a relay or something like that. So in this extent, that typically means that there's no connection there. They don't do anything. They're just pins because of the fact that this is an industry standard 10-pin plug. But so yeah, that's why those aren't connected. And then the other ones, they're not needed. There's 2 grounds, but this ground is also connected to that ground, so they're both the same. It's, again, just depends on how you connect things. But there are also some things here. So you have the SD, 2 SD things. Those are not plugged in on this because the fact that Klipper actually doesn't use SD cards. It uses what's called a virtual SD card, if you weren't already aware with that. And so, I mean, there are ways to get this to work to where you can put an SD card, and instead of using the virtual SD card, it'll read from there, but it's a lot more involved. You have to do some, stuff with the host computer to mount the drive and do some other coding stuff. So that's kind of beyond the scope of this video. I don't want to overcomplicate things, and really that's not how Klipper is designed to be used in general, but there are ways of doing it, just so you know. But yeah, so we're not going to be setting up the SD card at all, so that function on here is non-functional. And then the kill NC, I've never had anything plugged into that, so I don't even know what that does. It has an NC or kill, so it's kind of strange, but it might be like a hard reset button. But underneath it, we do have another reset, and that is connected down, obviously, to this hashed out, or not hashed out, but the multi-lined color there to there. And this is not anything that's defined in configuration. There's another one that says reset pin, and that's actually the LCD reset pin. That's what they're going to be talking about when I show you the configuration. But this reset is the hard button. So that's actually the physical button on here underneath the rotary button. So that's the reset button. So when you connect it, you don't have to connect these wires. But just so you know that if it is connected and you press this button, it will put your microcontroller into shutdown mode, basically. It's not a reset as in it's going to turn it off and on. It'll shut it down according to Klipper. It puts it into a stop phase. So if you're printing and that button gets hit, then that'll completely stop everything. Failed, because you're not going to be able to recover from that. You have to actually reboot the controller, the firmware, in order for it to get working again. That's the same thing as clicking the button over here, the reset button on the board. So they're kind of more or less tied together through that wire. If you don't want that to have, if you don't want to have that ability to mess up prints with this, or it has that, I use it on some screens like emergency stop. But if you don't want that, then don't plug in these reset. You don't need that wire for that, because that's all that does. Enough of that. So now, how do we get this thing working? That's probably going to be the hardest part for most people trying to search, because if you find diagrams, maybe you can figure it out with pins. But how do we get this configured? So that's what we're going to go over. But first, I want to give a huge shout out to my video sponsor, PCBWay. They have been great. I recommend them highly. I got links down in the description. But check out this video and we'll be right back. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWay. PCBWay isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBWay has got you covered. A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWay takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWay offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWay services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWay for sponsoring this video. And now let's get back to the video. Okay, and we're back. Let's get this thing configured. So what do? First thing first, you need to make, well, you don't need to, but I recommend making a configuration file separate for the screen. It just keeps things clean. And that's what I've done here. As you can see, it says screen.config. To do that, if you don't already know, there is a create file. This is with main cell, but Fluid, if you're using Fluid, has the same type of interface more or less. So you go ahead and create a file, name it to whatever you want it to be. It doesn't really matter. But the important part, it's appended with .cfg. That is telling that it's a Klipper configuration file. So Klipper knows what to do with it. All right, so go ahead, like I said, it can be named whatever you want, but keep things organized so it's easy to find things in the future, because we do need to use this. Go ahead and while you have it here before you save, go ahead and just copy that so you have it ready, because the next step, I'm just gonna hit cancel because I already have one I don't need to create, but you would hit create. And the next step, you wanna go into your printer.config file, and we're gonna need to include it. So if you're still figuring this stuff out and you haven't seen my what is the printer config video, which I'll link up at the top if you want to check that out if you haven't seen it. Include functions, there are these here. As you can see, there's a few of them that say include. These here are designed to do exactly what it's saying is include, and then the space, and then the file. So it's include this file. Well, what it does is it doesn't just give a file. It actually, when Klipper boots up, it'll pull all the information, all the configuration information that's in that file, and basically smash it together with the printer config, because the printer config is the king of the configuration files. That's the one that you have to have no matter what. So all of these other ones are just easy ways of keeping things nicely clean, because technically, like I said, you don't have to make these files. You can just put the configuration directly in here. Just scroll down to the near bottom and put it here. But ignore that one. This is wrong. But basically, if you have a save configuration already set up, you got to be careful, because if you put it all the way at the bottom, then you can mess up your save configuration. So that's another reason why I recommend doing includes. It just keeps things nice and clean and organized. So go ahead and do the include. You need the brackets, open and close brackets, the word include with a space after that, and then the file name, the full, if you named it Mini12864.cfg, you would have to put all that there. Okay, so go ahead and do that. Save and close. Don't hit save and restart yet, because now we need to actually do the configuration. That is, I have already set up, of course, here in the screen. So I'm going to make it easy for you guys, and just obviously you can see it here and you can follow along and type in, but I'm going to also have this so you can copy and paste it. I'll have it either down in the description, or I will link to a GitHub. So, because I also want to put that the photo. I want to have this for you, so you'll have that also. So I might do just a quick little GitHub so you have both. Anyways, you'll have access to it so you can copy paste, all right? But I'm going to just now describe basically what is going on here. So the first one is not actually necessary for the screen to work. What this is, when Klipper, when you install Klipper, it comes preloaded with a default configuration for the menus. And one of those, because Octoprint was used almost primarily originally for Klipper's firmware, that is one of the menu options. So you can go in and control Octoprint stuff. You can still use Octoprint. So if you are, then you would not put this part in here. But for a lot of people now, they're just not using Octoprint anymore. They're using things like main cell or Fluid. And so this basically puts a menu at the top of your screen when you first start up. It's the first thing you see. So to disable, to get rid of that, this is how you would do that. So basically saying a menu item, which is the main menu of Octoprint, disable it. Pretty straightforward, right? So that's what that is. But the next part is for the screen. This is how you get the screen to work. As you can see, it's just display. The type of the screen is UC1701. Then the next step is just setting up the pins. So like I said, it's going to be a copy and paste, but a quick breakdown of some of the things. So like that reset pin I was talking about, this reset pin is not what that's talking about. It's talking about this one right here, the LCD reset. And then the next one is going to be attached to this one. It's called A0. And that's what this LCD RS. So if you have another screen, they're very similar, but they might have different pin orders. So keep that in mind. So if you see something like that, it says RS, you can't find that anywhere. That's what it is. It's the A0 pin. So let's go back over to configuration. So that's that one I was just talking about, the RS, LCD RS pin. And the next one are the encoder pins. This is something that you need to keep in mind with encoder pins and with the next one, which is the click pin. That's the button pushing on the encoder to select. You do need to have these, they're called carrots, the little up arrows. This tells this tells Klipper to use the built-in pull-up resistor to basically keep the pin high unless it's used. So basically what it does is it keeps everything stable. So if you have a problem where you're, for instance, changing through your menus and you let go, but then it kind of bounces a couple lines again, even though you're not doing anything, come and double check if those little guys are there, because if they're missing, that's probably what's going on. Same thing with the click. If you go ahead and click it once, but then you see that it clicks multiple times, it's more than likely it's because that's missing. On the click pin, it is also important to have this next thing, the bang. It's the exclamation mark. That is telling it to invert the signal. So instead of it being pulled high, it's pulling low. So that's not really drastically important, except the fact that these are in place. So if things aren't working right, first thing to do is check with those. Things aren't working right with the encoders. Obviously, you check your wires to make sure they didn't fall out or that they're in the right spot too. And so another thing about the encoders is if, for instance, you're turning it clockwise and it's going down and you don't like it, you rather it go up if you do clockwise, then what you would do is you would switch these pins. I think I do have it set the way, so clockwise is up and counterclockwise is down. But if you don't like that, you can change it. You can just swap these two numbers with each other. So PA15 is first and then PB5, and that will literally swap the direction of the encoder. Pretty simple, right? You can also swap the wires, but I feel it's easiest just to do it in configuration. Leave the wires alone. The next one is your contrast. That is going to be telling the screen how much of a difference between the text and the background of the text. So basically how much is shown to not shown. I found that 63 is a pretty good number to use for that. It looks really crisp and clean. It's not overly bright or too dim. But if you have a problem where you see you've powered up the screen and the screen is on, you see that like the lights are on, but you can't see anything on the screen, come and check this out, contrast, because if you have something like 6, or if maybe you didn't want it to be so intense and you put like 15, that could possibly be still too dark or not enough contrast to where basically the whole screen is just black. So there's no text. It's working, you just can't see it. So come and just make a bigger number. Like I said, 63, I say stick with that because it seems to work fine with all the screens that I use. The next one are just your SPI pins. So pretty straightforward. As you can see, they have the names of them here, but on the diagram, you see that it says MOSI. So you don't have the pins like you normally do, like with here you have PA5. So I just got those for you and put them in. But you can see where they're connected to. Next step is setting up the lights on the screen. So this part is only for the screen, the rotary encoder and the actual physical screen itself, the digital display. But then we need lights so you can see what's going on. So these are the backlights. And that's what the NeoPixel is for. And these are being set up just like any other standard NeoPixel, which is really nice because that gives you control. If you know how to use NeoPixels on these things, you already know. But if you don't, what you can do is you basically set up a name. Again, anytime you have these type of options where you have the the item that you're going to be controlling and then a space with a name, most of the time you can name it whatever you want. Try to name it things that are very easy to understand and follow, because this is what you would use in other things like macros. Say for instance, for your start print, you want the screen to turn blue when a print starts, and then you want it to go yellow or something, or flash when a print is done, or something if red if there's an error. Who knows? All sorts of things that you can do with that. You would need this name so it knows which LED group to control. So that's why that's important. So make sure that you remember what it is and keep it somewhat organized. Can't stress that enough. But otherwise, rest is pretty simple. You have the pin that's being controlled on. Chain count is how many LEDs. This one only has 3. There's 2 underneath the knob and 1 for the screen. The RGB color, this is color order. RGB is the order of this specific screen I have in my hand. I have had other screens where they're actually reversed, where it's GRB. So keep that in mind. If the colors aren't looking right, you choose, for instance, in these next areas where you choose your colors, and you choose only red to be on, but the screen is green, then that's what you would do. You would switch these here for GRB and RGB. But we're going to leave that the way it is for now. And then the next 3 is basically what your initial color intensity is going to be. So being that these NeoPixels are 3 colors in 1 pixel, you have control over all 3 colors. And the way these scales work, as you see, it's a 0.0. It works from 1, only 1 being 100% brightness, and then down to 0 being 0% brightness. If you put 2, it's going to error out. You might get an error message, or it just won't work, because 2 doesn't mean anything. It's not 2. That would be like saying 200% of it, and you can't. You can only give it 100% of the scale. I don't recommend, though, using 100% on these things. You can. It's your panels, but there's really no reason to do it. As you'll see when we power up, that even at 80%, it's still very bright. So we'll just mess around with it at 80%, and then I will just take away the blue here. Maybe I'll just put blue to 20%. That's what the 2 would be. And then no green. Let's put that to 0%. So that's how it works. So the point and the number after that will be the percentage. So yeah, you have 80%, 20%, 50% will be 0.5. So pretty self-explanatory, right? So that's that. Then one more thing that we have that needs to be set up is if you want to use the beeping sounds. And that's what this is here. Now, this is one thing to point out. I need to point out. One thing I need to point out is this is the newer version. So if you have the newest version of Klipper, I know for sure from the version 0.12, or I guess version 12, that you have to use PWM cycle time. That is the new function being used for the beepers. And the reason why I point that out is because if you have an older version of Klipper, what you're going to need to use is, where do I have it? I have this macro that kind of checks for both. But this one here, it's called output pin. And it's just an older way of doing it. And it's basically, it's kind of the same way, but it's just a little bit more organized. And this one is more dedicated. This function is dedicated to pulse wave modulation, which is what is controlling the sound. Whereas the other one is just a standard output pin. So you can just say go on or off, or use pulse wave modulation. So it's a little bit more universal, but they're phasing this one out and using that one for pulse wave modulation. So I just want to point that out in case you have an older version of Klipper and it's not liking this one. Then instead what you would do is set up output pin, but you would have to go to the configuration. I can link it down in the description. So because you will still need to set up PWM in the configuration part down here. Okay, so I just needed to point that out. But anyways, this is what we're using. So again, the pin that it's being controlled on, the value, you just leave 0. Same with the shutdown value. These are the values of the beep time, how long it's going to beep for. So this is the startup. So when you first call this function, what is it going to do? So obviously we don't want it to do anything until we actually give it an actual real command for a time and a frequency. So that's what that is. Shutdown value is kind of neat. For instance, if you want to do it to where if the board gets shut down or something like that, or has a shutdown and you want it to beep, you can set up a frequency there. And you would do, like, for instance, if you wanted to beep for 2 seconds, you would do 2000. And it will just do the cycle time here. It'll just do its default beep for that long. So that's what that is. But I say keep it 0 just because you don't want it beeping every time you turn off your machine. Or maybe you do. So that's what that is. And so the cycle time, just leave it at the 0005. That's kind of a relation. Again, this is the default stuff. And so it's leaving it at a 2 kilohertz beep, which is a pretty standard, buzzer beep sound. And so that's it. That is your full configuration set. So if that's all you were looking for, then congratulations, you've made it to the end of what you need and you're ready to go. Go ahead and power things up and it should be working as long as everything's plugged in. But I do, of course, want to go a little bit more in depth just to show you some extra stuff that I've done here. More or less for fun, but mainly because the fact that I have set up the beeper, how to get that working. Because Klipper doesn't have the M300 built in as default. So we do have to make a little macro to do that. I'm not going to go into depth on this macro because, as you can see, it's a little bit more complicated if you're not used to this stuff. But I'm sure you've seen this percentage sign groupage stuff all over the place and seen macro labeled and talked about G code and whatnot. So I am working on learning or getting a better grasp of how to explain all this stuff, because this is a whole new language. It's actually called Jinja, I think it is. And it's a different programming language that's built in to do this type of parameter stuff. So beyond the scope of this video, I don't want to confuse you. But basically, this is just telling it when you use an M300 code. So that's kind of a very traditional standard send or emit sound code. And the way that the code works for G code, this is also used exactly the same way in Marlin, is you do M300 that says make a sound, and then the P value, that's the first parameter, is how long, and it's in milliseconds. So a 2000 milliseconds will be 2 seconds. If you do 500, that'll be half a second. So makes sense, right? The next one is the frequency that you want to try to achieve. It's not pitch perfect, but with this setup here, it's pretty close. And so that's what the S value is. And so all this macro does is it looks at that command. So anytime an M300 command comes in, it triggers this, because that's why that's there, right? And then once that triggers, it starts going through all these different things. So the first thing it says to look at the P, look at the S, and then, you know, turn it into values that can be used up here to actually make sound. So that's all that is. So that's what goes down through here. And then the next one, I'm gonna, like I said, I'm gonna put this whole thing here so you have it all. But this one is virtually doing the same thing, but instead of using M300 G code, you're just using the command beep. And then it also adds a function of I, which is an iteration. So if you want it to beep 3 times in a row for 2 seconds each at a certain frequency, then you can set that up. And so you would be like beep, and then I equals 3, that's 3 beeps in a row. Duration, how long? Let's say half a second each. So it would be 500, DUR equals 500, and then FREQ, which is the frequency, equals 2000, for instance. As you can see, here's some defaults. And so, again, you don't really need to know a lot about this. It's just some extra fun stuff, but they're going to be in there for you to play around with. And I will link where I got this. Hopefully I can find it again, because this is not my G code. This one technically is not mine either. This is just the basic M300 G code that I've modified a little bit. So yeah, there. If I find it, hopefully I can find it, because I want to credit the creator of this one. And they have more information about that, so you can get more in depth, okay? So that'll be in the description. But that's that. And then the other 2 little things that I have here are just something to show you what can be done with these screens. So these are delay G codes. Delay G codes will basically delay for the initial duration time that whatever you set here. So they're in seconds, is 1 second. So when the configuration is loaded and everything starts up, then it starts counting. So after 1 second of everything is booted, it will send a G code. And the G code here is M117, and M117 is send text to the screen. It's that simple. So you can send a message to the screen. So you can set it up with macros, for instance, print started, now probing, homing, all those types of things you can see on the screen of what your machine is doing. Obviously, you can just see your machine doing it, but I know it's not needed, but it's something fun. This is completely just for fun here, just to give your machine some personality, you know, give it your own personality. And so this what it's doing is saying count 1 second. After 1 second has lapsed, then you say hello, or print the message hello on the screen. And then the next one is the exact same thing, just a different name. This is welcome 1, welcome 2. And this one waits for 2.5 seconds from startup. So it'll be 1.5 seconds after this happens. So hello, and then ready to make. And it's letting you know that it's gone through and booted up successfully, basically. So that's what that is. So you can play around with those if you want, or you just delete them if you don't want them. It's not important. If you don't have anything like this, all it's going to do is just say ready when it's ready. And then if there's any other M117s in any of your other macros that somebody else has set up or if you've set up, then it'll just print those up when they are called. So that's simple. So that's it. Let's get the thing powered up and see it in action. Oh, before we do that, of course, you do have to hit, once you've done your configuration, this is when you do actually hit save and restart, because that's going to do that, save the configuration and restart. None of the configuration will be initiated until you actually restart Klipper. So do keep that in mind. If it's not working, you just did save and quit and nothing's doing anything, it's because you didn't do save and restart. Okay, so there it is, all booted up. As you can see, there's that, it made kind of an interesting pinkish color with that. And there you go, you can see the ready to make. I'll demonstrate when you click that button. You'll see nothing happens here. But on the screen, now we have this shutdown happening. So Klipper reports shutdown. So that's why I tell you it's important. If you don't want that function to happen, if you don't want to be able to have anybody come in and just click a button and ruin your print, unplug that wire to the reset pins, okay? That's I wanted to point that out because I've had some people I've read about people coming in where their kid went and just, oh, what's that button do? And completely ruin like a 15-hour print. So keep in mind that that can happen. Anyway, so let's get this restarted again. So to restart when you're in an MCU shutdown, you just do reset or firmware restart. And then if you see the screen, it should go through and boot up again. There it is, ready, hello, and ready to make. Pretty cool, right? Let's go into the one thing, since I don't really want that color, and you may not want the color either. So what we'll do is go in and play with the colors and see what we can do. So let's do it all blue instead. So we can do, yeah, let's do 0 red and maybe a little bit of green, 20% green, and then 80% blue. See what that does. And so you can see here, I'll put it on the bigger screen now. Oops, that's not the bigger screen. So let's do the save and restart, and then let it do its thing. Just take a couple seconds here. There it is, it's changed its color, and it gives those messages again, and it's all ready to go. Ignore the negative temperatures. As you can see, I'm using the bare board. I have nothing plugged into it, so the reason why they're negative is because I've configured my configuration to allow that. Otherwise, it would get an error about the sensors, the ADC error that your thermistors are basically thermal runaway. So don't worry about that. Otherwise, as you can see, if you click on the button and roll the wheel, everything works great. So yeah, that's it. It's all nice and configured. You're ready to go. So hopefully this video was informative. Hopefully this solves a problem that you've been trying to figure out. I know there's a lot of guides out there and a lot of people that have been talking about how do we get this thing going. And that's really what sparked me to do this video because, again, like I said, I want to make this to help beginners to get their 3D printers or their modifications going smoothly. So you can see it does work. A lot of people I've actually saying that it doesn't work, which was surprising, but it's not easy to do if you don't know what's going on. So now you know what's going on, and it's easy, right? It's just finding out where the plugs are and getting the right configuration. That's all. Really, when it comes down to most of the stuff, that's all it really is. But I understand it can be very confusing, and especially with the way information is out there. That's why I'm trying to make these kind of cataloging the different options that you can do with these boards, because there's so much more that you can do. I'm just barely scratching the surface with this stuff. So hopefully I'm able to get more and more to go and show you what's going on. Thank you to all my new subscribers. I do see you guys flooding in, and that is completely blowing my mind. So thank you. I'm glad you guys are enjoying this and finding help. I mean, that's really what it comes down to. That's telling me that you guys are finding this helpful. So that's what makes me really happy about this. So thank you, welcome. Thank you to all of my longtime subscribers. You guys are amazing. Keep leaving comments down below, letting me know what you think about the video. Let me know if you have any questions, suggestions, comments. Even if you have something like, hey, you keep doing this, just stop that, please. I can't guarantee I'll stop, but I'll, depending on what it is, I'll give it a shot and see what I can do. So I do love the feedback. I really appreciate it, honestly. So that really helps me out grow. So that's that. And yeah, thank you to PCBWay again for sponsoring my channel, these videos. This is, a massive help. It helps me get equipment to really, show you how to do all this stuff. And yeah, I got affiliate links down in the description. You don't have to use them, but it's really appreciated again if you do, because it does help the channel. It costs you nothing extra, but if you're looking to get Big Tree Tech or BQ items, go ahead and check them out. Like I said, costs you nothing extra, so why not? If you're looking to get it, it's just a link. So that's that. And yeah, I'm gonna cut this video off now. I'm gonna start rambling if I don't. So hopefully that was helpful. Thank you for watching, and get out there and go print something. Have a good one.